If you'll take a look at charts showing the fastest growing programming language in open source projects, you are in for a big surprise. In the second place, following Rust closely, you'll find this tiny little language called Lua. So what's the deal with it? Why is Lua so popular all of a sudden? And, more importantly, is there a benefit in learning it? Let's spend a few minutes looking at Lua's core features and main selling points, and by the end of the video, you'll see that thanks to its simplicity and popularity, Lua can be a valuable addition to your skill set. For a bit of context, I'm a software developer with 15 years of experience, mostly in JVM-based languages on the backend and various UI libraries on the front end. I'm a fan of exploring what the dev space has to offer, and I developed a pretty straightforward, efficient system to assess the viability of a programming language. First, let's get the basics out of the way. Lua is a powerful, efficient, lightweight, embeddable, dynamically typed scripting language that supports both object-oriented and functional programming. Don't worry, I know this is a mouthful, but we'll deconstruct this definition and get the gist of it all. So, Lua is efficient and lightweight since it relies on just 22 reserved keywords and 8 basic types. Even more interesting, however, is its approach to data structures. There are no classes, structs, interfaces, or traits. There are no arrays, lists, or hash maps. The only data structuring mechanism available in Lua is the table. This might sound weird at first, but you'll see in a second that this basic structure is versatile and powerful enough to cover all your needs. Thanks to its lightweight nature and the low barrier of entry, Lua can also be easily embeddable in other host clients, ranging from popular games like Roblox to modern IDEs like NeoVim. Okay, let's get to the fun part and look at some code. We'll review the main 7 language features you need to be aware of in order to know your way around the language. First on the list, let's see what a basic Lua program actually looks like. We are defining a local user variable pointing to the reference of a table. Since we can use string field names as indexes, this will make the table behave like a record or a dictionary. In Lua, functions are first-class values, so we can easily attach methods to our user object. The language is pretty flexible, and the hello method can be defined in the table directly as well. Note that the .notation operator is used to concatenate strings. You'll see throughout this video that Lua is full of these small quirks, which make the language really interesting. Next, we are using some of the standard library support, we'll get back to this later as well, to read information from the terminal, convert values to the correct type, and populate our record. Finally, we'll make sure that the length of the name is larger than 0 using another interesting operator, and we'll call the hello method if the validation passes. We can run this code in the terminal by calling the Lua command followed by the file name. This should give you an idea about the very basics of the language. Next, let's look at values and types, and then we'll work our way up to some of the more meaty topics. There are 8 types in Lua: string, number, boolean, nil representing no value, table, function, threads, and user data. All these are pretty self-explanatory, except maybe for the last 2. We'll discuss them in detail in a second, but for now remember that despite its apparent simplicity, in Lua you can handle workloads via collaborative multi-threading, and you can store and work with C data via user data types. Lua is a dynamically typed language, which means that variables do not have types, only values do. There are no type definitions in the language, and all values carry their own type. You might have also noticed that we are using the local keyword quite a lot. This is because in Lua, variables are global by default. As you might know from other languages, polluting the global scope is error-prone, so you should always try to limit the scope of your variables. As an additional benefit, using local variables leads to better performance, since local variables are stored on the stack, while global variables are stored in a special global environment table. Next, let's briefly look at Lua's control flow. Things are a bit more verbose here, but simple nevertheless. You have access to your usual if then else statements, while loops, and also to repeat until loops, which will execute your code at least once. The for statement can be numeric or generic to allow you to iterate over table values. Quick side note, I know that Lua syntax might not be your cup of tea, especially if your background is in languages which focus on concise semantics. However, keep in mind that we are talking about a 30-year-old language and the trends were a bit different back then. Next, let's take a deeper look at the Lua table. As I already mentioned, this is the only data structuring mechanism and is among the most powerful features of the language. We can initialize an empty table like this and then simply add fields using one of these approaches. Then, we can access field values either via the notation or using square brackets. Of course, when we initialize a table just with values, this will act as an array, with indexing starting from 1, just as God intended. When working with data structures, operations like inserting, removing, or sorting your data are fairly common, and these are provided in Lua thanks to the standard table library. Remember that tables, just like functions or threads, are objects. In other words, variables do not actually contain these values, only references to them. Assignment, parameter passing, and function returns are always done by reference, so always keep an eye out on how you are mutating your data. In comparison, Lua's primitive types are immutable and are always passed around by value. This is a good time to briefly discuss Lua's automatic memory management. Thanks to its garbage collector, Lua's memory is handled automatically, so you don't have to worry about allocating or deallocating memory for your objects. Metatables are another cool feature aimed to increase the flexibility of tables. The easiest way to understand them is through an example. Imagine we have a simple user object that's printed on the screen. An internal toString method is called on the object, which will return the memory address where the object is stored in the heap. We can change this by creating a meta-user table, override one of the many operations you can control via metatables, and then link the user object with a new behavior. This is a powerful feature with great potential, and it is worth exploring in more detail. Just to give you an idea about the extent of this flexibility, we can define a call method in our meta table, and now, all of a sudden, our user object can also be called like a function. I mentioned multiple times that Lua comes packed with a standard library offering useful functions implemented directly in C. One interesting such library offers support for coroutines, which allow for non-preemptive multitasking. Unlike threads in many other programming languages, Lua coroutines are not executed in parallel, but rather allow multiple sequences of operations to be interleaved in a co-op manner. Looking at another basic example, coroutines can be created based on functions which handle workloads and then yield control, or in other words, give up CPU time to allow other tasks to run. Switching gears to some lower level yet still interesting aspects, Lua is known for its speed and efficiency, mainly thanks to its C implementation. This makes the language portable and easily embeddable in other C-based applications thanks to Lua's C API that allows you to call Lua functions from C and pass data between the two languages seamlessly. We can see this in action by looking at the following example. In a C file, let's make sure we have access to the Lua APIs and then define a point structure. The new point function allows us to create a point instance by validating the data received from the stack and making sure to register a new user data value. Finally, we'll register the new point function with Lua, compile our C code, and we should be ready to go. In a new Lua file, we can now load our C module and use the provided functions and data structures directly. Finally, let's evaluate Lua's ecosystem to understand if there is enough third-party support and the necessary libraries we can use to avoid reinventing the wheel. Lua offers a straightforward module system to package up code and share it easily, especially thanks to the Lua Rocks package manager. There are very successful libraries out there, ranging from well-established web frameworks like Lapis to web application servers like OpenResty. The community is alive and involved as well, and you'll see various experiments like porting the JSX templating language to Lua or Moonscript, a dynamic scripting language that compiles into Lua. If you've enjoyed this video, you should watch one of these ones next. Until next time, thank you for watching.